So in last video, we discussed a few very short answer type questions uh, for the chapter magnetism and matter. Actually, that chapter will come later on. Uh, we have to start the fourth chapter today, that is the moving charges and magnetism. So again, we will try to learn some of the very small points of this chapter in terms of very short answer questions, which may be helpful in attempting the multiple choice questions which are being asked nowadays in CBSE board exams. So the first question is, what is the basic reason for the origin of a magnetic field? What is the basic? That is the basic reason behind the generation of a magnetic field. So the basic reason for the generation of magnetic field is the movement of a charged particle. That is the flow of the electric current. So the movement of the charged particle or the flow of the electric current is the basic reason for the generation of magnetic field. The second question is, what do you mean by uniform magnetic field? So you all have learnt about the uniform electric field. Similar, and uniform electric field is a field where electric field lines are parallel and equidistant. Similarly, the magnetic field, that is the uniform magnetic field, is such a magnetic field where all the magnetic field lines are parallel and equidistant. So whenever we have to show the uniform magnetic field in any figure, we will show it by parallel and equidistant magnetic field lines. So whenever the magnetic field lines are parallel and equidistant, that magnetic field becomes uniform magnetic field. For example, the magnetic field at the center of a long current carrying solenoid is a uniform magnetic field. The third question is, mention some of the ways by which magnetic field can be generated. So the magnetic field, how can we generate a magnetic field? We know the field around a magnet itself becomes a magnetic field. So field around a magnet becomes a magnetic field. So magnetic field can be generated with the help of a magnet, simply. Second, the magnetic field can be generated by a conducting wire, current carrying. Oh, I'm sorry. Not only a simple, if you put a simple conducting wire where no current is there, it cannot produce the magnetic field. Of course, we need a current carrying conductor. So magnetic field is produced simply with the help of a magnet. You bring a magnet, magnetic field will be generated around it. That is the first way. The second is a current carrying conductor can produce a magnetic field. The third is, whenever a charge, moving charge is there, magnetic field is produced. And fourth, if we change the electric field. That is, changing electric field can also produce the magnetic field. So we discussed the four ways by which the magnetic field can be generated. The first, simply with the help of a magnet, you can generate the magnetic field. Second, with the help of a current carrying conductor, automatically the magnetic field will be generated around it. Third, whenever a charge is flowing, that is the moving charge, it always generates a magnetic field. And fourth, the varying electric field or changing electric field, that also produces or generates magnetic field. The fourth question is that you have a charged particle with plus q charge on it, and this charged particle is moving in a magnetic field capital B. We all know that magnetic field is denoted by capital B. So there is a magnetic field denoted by capital B, and we have a charged particle having plus q charge. It is moving with a velocity v, but in which direction? It is moving perpendicular to the magnetic field. So we have a magnetic field B, capital B. We have a charged particle plus q. This charged particle plus q is coming with a velocity v perpendicular to the magnetic field lines and enters the magnetic field. So the charged particle starts moving in a circular path. So because it is moving in a circular path, so for moving in a circular path, there must be a centripetal force. If there is no centripetal force, it cannot move in a circular path. So I am again repeating the situation. We have a magnetic field capital B. We have a charged particle plus q, and this charged particle is entering the magnetic field capital B with a velocity v perpendicular to the direction of the magnetic field. And after entering the magnetic field, the charged particle starts rotating in a circular path. And we all know that whenever a particle is moving in a circular path, there is a centripetal force responsible for it. So the question is, how much will be the centripetal force on the charged particle? That is the first question. And if there is a force, of course there is a force, centripetal force, will this force work on the charged particle? Because if there is a force applied on something, it may do work or it may not do work depending on the displacement. If there is a component of displacement in the direction of applied force, then there will be a work done. And if there is no component or no displacement in the direction of force applied, then no work done is there. So even the applied force is there on a particle, it may do some work on the particle or may not do the work. So the first question was, how much centripetal force is working on, because it is moving, the charged particle starts moving in a circular path. So how much centripetal force is acting on the charged particle? That was the first question. And the second question, of course, yes, we will calculate it. And the centripetal force is there, it is applied on the charged particle. So how much work will it do on the charged particle? So we will discuss it in detail, but as you have already gone through the chapter a little, you must be knowing that if this plus q charge enters a magnetic field capital B with a velocity v perpendicular to the magnetic field, the centripetal force F is equal to QV capital B. Some of you must be saying sine theta will also come there. Yes, sine theta will come. But here we told that the entering charged particle is entering perpendicular. That is 90 degrees. So sine theta sine 90 will become 1. So for a particular special case, you can learn it, you can remember it, or you can understand it, that the centripetal force acting on the charged particle will be F is equal to QVB. The second thing is that, what do you think? The charged particle is rotating in a circular path. So whether it will do some work or not? So just think over it. I am not answering it. How much work will be done by the centripetal force on the charged particle? This you will have to think, and we will discuss it later. Then there is a next question, question 5, that again we have a magnetic field. Now we have a proton, and this proton is passing through the magnetic field. That's okay. We have a magnetic field capital B. We have a proton with positive charge, and this proton is passing through the magnetic field, or after passing the magnetic field, it keeps on moving in its initial direction. So we have a magnetic field capital B, we have a proton, and even after passing through the magnetic field, the proton keeps on moving in its original direction. So if you wish that it should keep on moving in the original direction, then I wish that no force should be there. If there is no force, there is no acceleration, so there is no change in the velocity. So the proton keep on moving, it will keep on moving in the original direction. That is, the force should be 0. And as you all know now, that the force is QVB sine theta. So this force can be 0. The charge on proton Q is not 0. The velocity is not 0. The magnetic field B is not 0. So the only possibility to make the force 0 is sine theta should be 0. And sine theta is 0 for the direction theta is equal to 0. It means whenever the angle of velocity of charged particle with the magnetic field is 0, the force applied will be 0. And if force applied is 0, then the charged particle will keep on moving in its original direction. So that was the question. The proton, even after passing through the magnetic field, keep on moving in the original direction. So it should move. To keep on moving in the original direction, the net force should be 0. For net force should be 0, sine theta should be 0, so theta should be 0. So the angle that the proton makes with the magnetic field should be 0. That is, if the proton enters the magnetic field at a 0 angle, then it will keep on moving in its original direction.